some other graphing ones. What if I had to graph x equals 7? Well, the deal on one like this or others like this, I call them special because, well, there's a special type of graph there, but it's also special because there's something missing. The y, the variable y, is missing. And when we have that, we have one of those special case lines. And which kind do we have here? Well, it's either the special ones I call special are horizontal or vertical. And this one, x equals a number, is vertical. Yeah. So this is a vertical line. X equals a number is vertical. And so that's really all you need to know. To graph, if you forget, just think about the table. That's saying the x value is always 7. So whatever the y is, x is 7. Okay, and that'll line up vertically. Of course, the other flip side of that, y equals a number, that would be the horizontal counterpart, right? X equals a number is vertical, y equals a number is horizontal. Now, if I have, say, y plus 3 equals 0, well, that's not y equals a number. However, one quick little move there, subtract the 3, and we do have y equals a number. So, yeah, that's the horizontal line that goes through -3. All right. Now let's talk slopes here. What about the slope? If it asked, does it tell me what the slope is? So if it was to ask me what the slope of that line is, we would say what? 0, okay? Yeah, the slope of a horizontal line is always 0. What about this vertical one here? I would ask for the slope of my vertical line. Is that 0 too? No, it's undefined. A little different. Slope of a vertical line is always undefined. Yeah. All right. Okay. Questions or concerns then on graphing our linear equations? All right. Well, we also graphed some inequalities. We did few of those. That was section 4. But yeah, the deal is on an inequality, when we graph it, yeah, we're going to be graphing, we did linear ones, so we're graphing lines, but what about the inequality? What does that add to it? Well, on linear inequalities, yeah, we're going to have lines, but then we're also going to have shading, right? So linear inequalities, the graphs of those are lines with shading. So anytime we get a x and y linear inequality, it's a line, but we have to shade with that. 2x minus 3y, let's say, is greater than -9. (2x minus 3y is greater than -9. Okay. Yeah, so we had divided up, just do two things. Do the line first, graph it. 2x minus 3y equals -9. however you want to. You can do a table, you can do x and y intercepts, you can do y equals mx plus b. Use that form. This one as it is, I'm just going to hopefully quickly here find my x and y intercepts. The x-intercept set x to be 0. So we get 2x equals -9, divide by 2. So I've got x is -9/2 for my x-intercept, or -4.5. Let's call it, comma 0. And then the y-intercept, set x to be 0. That'll give me -3y equals -9, divide by -3. So we have y equals +3. So the y-intercept 0, +3. All right, so that gets me enough here to base my graph on. So that would be -4.5, comma 0, and 0, 3 y-intercept. Okay? Now, the other little detail on inequalities is sometimes you have a solid line, sometimes you have a dotted line. What about in this case? How do I know which to put, dotted or solid? It's a dotted line because you don't have the equal to. Yeah, if it doesn't have the equal to part, it means you're going to do a dotted line instead of a solid line. Because the equal to part is the line, so it's just a boundary line here for the line. Okay. All right, then part 2 is the shading. And how do we go about shading it? How do we know which side is shaded? Flip a coin? No. Just check a point, right? Not on the line. 0, 0 is usually a good one to check. You don't have to check that one, but some point not on the line, 0, 0 is a good one, most cases. So just checking it back in the inequality, plug in 0 and 0 for x and y, and then decide if that's true or not. That says 0 is greater than -9. How about that? Believe that? Yeah. That is a true statement. 0 is greater than -9. So that tells me 0, 0 works, so I need to shade the side with 0, 0, don't I? Zero, 0 hadn't worked, I go to the other side. Here's 0, 0, so I shade this side. All right? Okay. All right, then.